Hello everyone. In this video we are going to start with shear force and bending moment. So first of all we will try to understand what exactly shear force and bending moment is and where these are applicable. Shear force and bending moment are applied, or shear force and bending moment is observed in designing of beam, slabs, columns, footings, in all structural elements. So in RCC as well as in steel design, steel structures, we observe these shear force and bending moment, and this unit is very basic for designing. So first, beam, it is a structural member which is subjected to transverse load. So transverse in the sense, length of the beam means the longitudinal you can say, or in lengthwise you can say. Transverse means across the longitudinal span, right? So transverse load are nothing but the external forces or loads acting at right angles to the axis of the beam, you can say, because axis is running along the length of the beam, right? Axis of the beam. So perpendicular to the axis of the beam, vertical forces which are acting, or you can say transverse loads. So it is nothing but a structural member. Now coming to transverse load, just what we discussed here, the load which is perpendicular to the longitudinal axis of the beam. So next we will understand shear force. Shear force can be taken into consideration, or it can be defined as algebraic sum of all the forces at one side of the section. Okay, algebraic sum. It may be the column reactions, or the active loads, or live loads, or dead loads which are acting downwards. So action and reactions will be considered here. So it is nothing but the sum of all the algebraic sum of all the forces at one side of the section of the beam. Okay, or here it is mentioned it as unbalanced force on either side of the section parallel to cross section, they have said. So it is nothing but the shearing force, or you can just say frictional force, which tries to cut the beam at particular section. So to avoid this failure, we have to design for shear reinforcement. So this shear force helps in designing the shear reinforcement. Coming next to moment. Bending moment is nothing but the algebraic sum of moment of forces to one side of the section, you can say, or just it is nothing but product of force and perpendicular distance between the line of action of the force. Here I want to give an example for moment is uh, door is the example for that. Handle uh, handle which is fixed at the end of the, or the edge of the door, and door is fixed with the help of hinges, and door rotates. How? When it rotates, when you apply the force on the with the help of handle, right? So you're pulling or pushing the door and it is rotating about the hinges, right? So force which is applied on the handle is perpendicular to the distance, right? Perpendicular to the hinge, right? Perpendicular to the door, and that is the perpendicular distance from hinge to handle, right? So product of force and perpendicular distance, right? And this can be said to be a moment. Now what is bending moment here? It is the unbalanced moment on either side of the section in plane of beam, they have said. Here also same thing. So bending moment about a section is defined as the algebraic sum of the moment of forces to one side of the section. So this bending moment uh, is said to be the product of force and perpendicular distance. It means force is taken in kilonewtons and perpendicular distance is taken in meters. So it is a product. So unit is kilonewton meter. Okay. So this bending moment uh, is further classified into two, that is sagging bending moment or hogging bending moment. Okay, so sagging in the sense it will be considered as positive bending moment, and hogging bending moment will be considered as, you know, negative bending moment. So just very simple definition: force into perpendicular distance is nothing but the moment. Next we will consider in this unit what type of loads act on the beam. There are three types mentioned here. For basic understanding, we will consider these three loads on the beam. Point load, first one. Second is uniformly distributed load. Third one is uniformly varying load. Okay, so first we will try to understand point load. So an example is given in the figure. A beam A to B and the point loads at 3 points acting. So these point loads are acting at a single point on the beam or at particular section of the beam. So these are called as concentrated load, which are acting at a point. Okay, so the loads acting at a point on the beam, that is, say consider the point loads which are acting as C, D and E. Okay, so those are nothing but the point loads. Coming to uniformly distributed load, and point load is uh, nothing but just a force, so its unit will be kilonewton or just newton. Okay, then uniformly distributed load. Uniformly distributed load is load which is spreaded, or it is spreading over entire length of the beam or part of the beam. Okay, at uniform rate, you can say, because you can see in the example figure, second figure, it is mentioned W per meter length. It means per meter length so much of a load is going to act. It means if it is acting for a whole length of the beam, you need to multiply with that particular span, because the uniformly distributed load will be given as uniform with the uniform rate, that is per meter length. So uniform load distribution over wide area. Description, in the description it is mentioned rate of loading per unit length is given. So uniformly varying load, or it can be said to be triangular distributed load, a load which spreads over entire length of the beam or part of a beam in such manner that the load varies uniformly on each unit length, known as uniformly varying load. Okay, at one end of a uniformly loaded beam, at one end it will be, say, consider W1 per meter length. At the other end of the load it will be W2 per meter length, but it will be uniformly varying on each unit length. Each per meter length it will be uniformly varying from one end to another. Okay, so intensity of the load in the description, intensity of the load at one point to that at the other. Example, W1 per meter at C to W2 per meter at D, right? So example is clear here. So these are the point loads which are seen for basic understanding. Further, there are n number of different types of combinations of loads, UDL plus point loads, UVL. All three combinations of loads will be acting some in the actual loadings. So next we will try to understand what types of beams we are going to handle in this unit. Cantilever beam, you can see the example. It is fixed at one end and it is freely fixed, or freely one end is fixed and another end is free, and the point loads are acting on it. So description: beams have one end rigidly built into the support. Large span or heavy loads provided by additional support are known as propel and beam as a propped cantilever. If there is a support at the free end from bottom, it can be said to be propped cantilever. Okay, so second type of beam is simply supported beam. Just the beam is resting over the supports and the loads are applied from the top. So simply support beam can be, if the beam rests simply on the columns, it is said to be simply support. In case of the reactions at support is right angle to the support, okay, reaction will be exactly right angle to the support, and beam is free to move in the direction of its axis, and also it is free to rotate about the support. It means the moment is zero here. So coming to the third one, continuous beam. The beam is supported over more than two supports or more than two columns, so it is said to be continuous beam. The example is clearly mentioned, so it is showing us 4 supports and 2 point loads in first span, uniformly distributed load in second span, combination of point load and uniformly distributed in the third span. So beams with overhangs, fourth one. The beam, simply supported beam, is overhang on both left and right side. So portion of the beam that goes beyond the support is called overhanging beam. Maybe one or both ends of the beam are overhang. So these are the types of beams. Coming to next, we will continue in the next video. For further notification and upcoming video, please subscribe the channel, share, like and comment. Thank you.